Hello everyone! How is everyone doing today? So many new friends. I want to see energies. Ralph is already with a thumbs up. I want to see a lot of energies. I know the automotive industry is supposed to be very serious, but Epic is not. Epic is a fun association. We're going to have fun this afternoon. I'm so happy today. This is such a remarkable event. Automotive lighting with the key car makers in Europe and with the whole supply chain in photonics next to them. So I have just a couple of things to tell you before we get the ball rolling. The first one is that we keep working, we keep growing, we keep making the biggest photonic association, and now we are 558. So welcome Caleste from Belgium, fantastic CMOS sensors. It's great to have you in Epic. The second thing is this is the number 21 of the Epic Online Technology meetings. We are so exhausted, but we're going to keep going until the end. We finish with, on the 15th of July, we finish with ADAS and autonomous driving. So do not miss the meeting at the end of this fantastic session, ADAS and autonomous driving, which we're going to bring all the companies making LiDAR, making CMOS cameras, making night vision, all the technologies needed for the photonics that today helps you drive and tomorrow will drive for you. Today we have the whole supply chain, and I can tell you one thing, nobody anymore, there are no vertically integrated companies anymore. Nobody can do everything alone, and neither can Epic. So I would like to thank Hector Frati a lot today. He's been helping Sana, he's been helping Carlos addressing the key companies in the sector. He's by far the best connected person in the automotive industry in Europe. I put here his LinkedIn page. Connect with him if you want to know the who is who in the automotive industry. He's actually the general editor of DVN, the Driving Vision News, a key place for finding out what is happening both in lighting as well as in ADAS tools. Thank you once again, Hector. You rock. You are a friend of Epic forever. I also would like to tell you one thing. Organizing 40 meetings in 3 months requires a lot of work. I would like to tell you that I have a dream team at Epic. All my life, I wanted to have the dream team. I was in Barcelona 92 seeing the NBA. I said, I want to be part of a dream team. This is the dream team of Epic. And these people are working from Monday to Sunday, from early in the morning on the Monday until almost midnight on the Sunday, looking for companies to connect the photonic industry with. So if you want to be part of this and people are asking, how can we help you? Well, my dream team likes drinking a lot. So if you want to buy them a beer, you are welcome to do so. So we have in the virtual world a way of buying beer to people. I don't drink, but they do drink and a lot. So www.buymeacoffee.com/Epic Photonics if you want to buy a beer to this fantastic group of friends who are having so much fun connecting the industry. All of you are potential Epic members. A few of you are Epic members. All of you have access to a long list of market reports. I would like to tell you that we keep buying market reports, especially during this time. We spend a lot of your money buying market reports. Please use them. They are all for free for all the members. We have recently acquired the market report on ADAS tools, the one on LED lighting for automotive, the one on LiDAR for automotive. These are all for you, for your use. Use them, I've used them. Believe me, they are totally worth it. And one more thing, all of you keep saying we need to fill our job openings. We have created the biggest website on finding a job in photonics, www.jobsinphotonics.com. We scouted the opening positions of the 500 members of Epic. That's all I had to tell you, because today is about automotive lighting. This event could not have been possible without the support of our sponsors today, who are Ficontec, the automation and assembly equipment supplier in Europe. They actually can assemble anything from LED arrays, modems, especially positioning and active alignment of tools for lighting applications as well as datacom telecom. IMS, all the way from beautiful Netherlands, they develop and build automated high-precision production and assembly lines from smart sensors, micro-optics, actuators. A great company. It's great to have them in Epic. Axetris, if you're looking for either micro-optics or assembly of instruments from lighting all the way to medical or datacom, these guys are fantastic. From Switzerland, Morphotonics, roll-to-plate tool for manufacturing of micro-optics in squares from displays all the way to panels. And finally, SUS Micro-Optics, nano imprint made commercially available in volume productions. They are actually the one who made the carpet in one beautiful, beautiful car, which I'm not allowed to mention for legal reasons. And we go to the agenda today. And I cannot be happier. When I see the agenda and I see Marelli, OSRAM, Audi, Volvo, Renault to talk about photonics, this is going to be an excellent day. But they show me the agenda like that and I'm like, well, this looks good. But when they show it to me like this, these are the companies who register for this meeting. This morning, I couldn't sleep very well. At 6 a.m., I got up, I went through the list, and I see which ones are making micro-optics, which are the car makers, lighting modules. The reason why I separated this like that is because I believe today there is a unique opportunity of doing business in photonics. From the companies who are making LEDs, all the way to the ones that can package it, all the way to the ones who can make an instrument with it, and all the way to the OEMs in the car industry, all of them represented a high-level decision-making. All of you are going to receive introductions after this email, after this meeting. All I ask you is that when I introduce you to another company, please follow up. Even if it's to tell them it's interesting, but we don't have time at the moment, please follow up. For me, introducing companies is what is driving what I think is the best photonic association today. Last thing, I would like to remind that this meeting is broadcasted in YouTube. So for the YouTubers there, the ones who are watching from the comfort of their own home, please post your questions in the chat. But if you want to get in touch with any of the participants today, if you want to get in touch with anyone, send me an email, jose.pozo@epic-asoc.com. Send me an email, I'll introduce you, jose.pozo@epic-asoc.com. I try to be as fast and as effective as possible. It took me 5 minutes, but I think it was worth it for everyone to know what we are doing here, making business. And with no further ado, I would like to give the floor to a company in Epic who has the position and track record already to bring laser-based manufacturing to the OEMs in automotive. It's an honor to introduce the CEO of Microrelleus, coming all the way from Barcelona. Thank you very much, Raúl, for being here with us. The floor and the attention of everyone here and in YouTube is yours.
Hello, everyone, and hello, Jose. Thank you so much for the introduction. Let me share my screen. Can you see it? Okay, great. Thank you very much again for the introduction. I am Raúl García from the company Microrelleus, and I will speak about femtosecond laser microstructuring and texturing for molds and prototypes for automotive lighting. I will speak just 1 minute about who we are and the femtosecond laser technology. Then I will speak about the lighting prototypes and mold microstructuring and texturing. Okay, that's our company. That's who we are. We are a service provider for industry. What we do is laser micromilling, microstructuring, laser texturing, and industrial engraving. Company creation was in 1983. We have several different services, technologies. Our facilities are in Barcelona, and in 2016, we were pioneers offering femtosecond laser service in 5 axes. So what a femtosecond laser is? Femtosecond laser is an ultra-short pulse duration laser, so the pulses of the laser are very, very short. So in terms of the industry, which benefits and which advantages do we have because of this such short pulse? So on one hand, we can engrave over any material, and I mean PMMA, PC, glass, steel, aluminum, whatever, and we can do it absolutely burr-free with a good superficial quality. If we compare this technology against others like conventional technologies, milling machine, die-sinking EDM, and so on, we can achieve smallest details than ever before. And if we compare it with the nanotechnology processes, we can do it in an absolutely industrial way. Big parts, quite big inserts with weight and so on, 3D shape as well. So for lighting applications, what we do with the femtosecond laser, we work on PMMA or PC prototypes, also small series, and mold and tool. So beginning with prototypes, we can see in this image the blinker of the mirror of the new Seat Leon that was presented a few weeks ago. Okay, in this case, we created this microstructure for these design purposes in the PMMA prototype at the beginning and then later in the mold. We can see here the difference between the plastic injected part in the mold against the previous micro-milled using the femtosecond laser over PMMA, and we can see that the microstructure is the same, the original prototype and the final mold. We don't use just the femtosecond for design purposes, but we can imitate as well in prototypes the graining, which is so important in the automotive lighting, like K29, K31, the VDI scale, etc. So in this image, we can see that in Microrelleus we developed the imitation of those standard grainings in the PMMA prototype. So we can see in the image the difference between the VDI engraved on mold, so injected part, against the some VDI directly engraved over PMMA. So usually customers send us the PMMA block already milled, already polished, and we work over it for different parts of the car. In this case, to finish with prototypes, we engraved in this Cupra Tabascan prototype the microstructuring of the three parts of the tail lamp. Those are microstructures for these light curtains. So LEDs are placed on the top, and thanks to this microstructuring, we can see the texture absolutely, we can see that the light absolutely homogeneous in all the sides. If we speak now about mold and inserts, as we spoke before, we can achieve details much more smaller than using conventional technologies. So for optical designers, for optical engineers, there is no limitation, the typical limitation of radius designing 0.15, 0.2, etc. There is no more this limitation anymore. So as we can achieve a radius 10 times smaller than using conventional machining. We can see the example in an insert on the right-hand side, and the same example placed in a 3D insert. So who are the ones that create those microstructuring for different purposes, like opening light, increasing light intensity, changing light direction? Usually are our customers, the OEM, the tier 1, tier 2, that send us the design of the microstructuring, but sometimes they ask us as well to be proactive in terms of design. So we have our own simulator, our own race tracer that we created ourselves with an algorithms generator, so we can give also this service with some limitations, but we can leave it as well. About texturing, we can texturize mold for decorative texturing, functional texturing, and we participate in R&D projects just to gain knowledge here. Here we can see the texturing of the mold for the previous part we saw before of the Seat Leon and final injected part. And in this image, we can see the functional texturing for light diffusion. In terms of MicroOptics as well, the quality and the smallest details that we can achieve. And this is the comparison against nanosecond laser. As we can see, much smaller structures without any burr, very, very good definition and surface quality compared to it. And the shape as well, very well defined with much more smallest radius compared to this nanosecond laser, which is the standard one in the market that most of the companies have. So to finish, we offer service of laser microstructuring, texturing, industrial engraving over final part or single part of serial production in PMMA or EC. Applied also over mold and tool. We offer R&D, a lot of customers pay us for R&D as well. And our customers, who are them? They are OEMs, tier 1, tier 2, final product manufacturers, mold makers, etc. So that was everything. I did my best to fit in these 6 minutes. So if you have any question, please feel free to ask whatever you want. Thank you very much.
Thank you very much, Raúl. I always like to start with Raúl because he always keeps the presentation on time and he always makes it very, very awake because your work is frankly exceptional. But you are already quite an expert in epic meetings. So you know what they are about? They are about collaborations. So if you could have the right, perfect collaboration out of this meeting, what would be? What is the perfect question you would like to get from the car makers that you have in the room today?
Well, finally, what we are looking for are OEM or tier 1, tier 2 that looking to our presentation can sometimes a little bit open their eyes and just to put their technology on their hands so they can be able to know new possibilities and new developments, new designs, etc., able to apply to their previous developments or new ones.
Thank you very much, because I'm going to ask one of the persons who made today the meeting possible. Is our consultant in the automotive and agriculture sector, Eneka from Eneka Consulting. Eneka, thank you very much for joining this afternoon. What a great meeting. How are you doing? You need to unmute yourself. I think we have you muted. We'll get back to her, I think, in a second. We have some problems with the audio system. I think hello?
Yes, audio. You've got me or not?
Yes, we can hear you. Yes.
Okay.
So,
yeah, excuse me. Yeah, I'm Dr. Eneka Barsoum, so I'm a consultant specialized in innovation in photonics. I have 25 years experience in industry in photonics. And in fact, I'm a former employee of Valeo as well. So I'm focused on automotive sector for 3 years now. So in fact, what you asked me to do a little bit in preparation, Jose, is to talk about a little bit about the evolution during the last year in lighting, and moreover maybe in photonics, in fact. So I will distinguish two kind of lighting, inside and outside the car. And for the outside of the car, what is really quite mature now is all the styling and as well the LED matrix lighting that is dealing with the safety purpose on the road. As well, what I can see, well, it's more ADAS, but it's the LiDAR for autonomous driving, of course. And really the hot subject at the moment is the integration of LiDAR and lighting in the headlamps. So that's one of the key points at the moment. As well, what is really now quite mature as well, I think, is the communication with the projection on the road. And for the, well, that's it, I think, for the exterior lighting. Mm-hmm. And for the interior lighting, you have as well all the physiological measurements, you know, about the heart, the emotions, the stress, and so on. So that's quite mature. And what's going on more in research now is, for example, communication by Li-Fi. In fact, from vehicle to vehicle for the exterior, or inside the car in the cockpit for high rate communication for infotainment, for example. As well, you have all the evolution inside the car to the comfort and even to health, with playing with the light to control the emotions, the state of vigilance and so on of the driver and the passengers as well. And as well, you have all the function of head-up display, for example, everything that is around the autonomous car driving, in fact.
Eneka, you have been instrumental for this meeting happening today, and also for the one on 15th of July. I would like to thank you on behalf of the whole EPIC. You are EPIC. We have two questions in the room. The first one is from Alexander from Nolden Cars and Concepts. Alexander, how are you today?
Thank you. Doing fine. Hello, everybody. I have a question to Mr. Raúl García. Thank you very much for your interesting presentation. Regarding the femtosecond laser application, have you made experience with light pipe application with the femtosecond laser in terms of going down lower than 0.2 millimeters in the partition of optics teeth, for example, on the light pipe? Thank you.
Thank you very much for your question. Well, with our machine and the lenses, the smallest detail that we can achieve is 0.015. So it's 15 micron, okay? So taking that into consideration, Yes, I can. I think we can. I think you were requesting something about 0.2, right?
Yes.
We usually work using lens of 50 micron, and we can go down until 15 microns. So that means it's like working with a tool of that diameter.
Mm-hmm. Okay, thank you.
We have a further question from Dynasil. Nirmal Parker, thank you very much for joining today. What's your question? I think we have you muted as well.
Thank you, but I don't believe I raised my hand for a question.
All right. You know what? We take this opportunity for you to tell us why you joined an epic meeting on automotive lighting today.
So hi, good morning. I guess it's good morning in Boston. Welcome. And it was nice to be joining the first epic meeting today. I work for a company called Dynasil. I'm the vice president of marketing there. And my reason for joining is twofold. One is I'm always curious to learn about what's happening in new industries. And two, because one of the companies under Dynasil, a company called Evaporated Metal Films, EMF, is a supplier of cold mirrors in the automotive space. So for head-up displays, which I'm a big fan of Volvo. I know somebody from Volvo is in the meeting as well. A big long-term 15-year fan of Volvo. I drive an XC60 nowadays with a head-up display. So I can actually experience the technology that we sell. So that was one of my other reasons of joining the meeting. And of course, to sort of do some networking as well. Thank you.
Nirmal, I'm not kidding. I also own an S60. And we go to the next speaker today. We go to one of my favorite companies in Europe. We go to Marelli. It is such an honor to have Andrea with us this afternoon. Andrea, thank you very much for joining. The attention of the whole supply chain in automotive is in front of you.
Hi, Jose. Thank you very much for the introduction. It's a pleasure to be here. I hope that you will be able to see my screen in a second. Let me know if you see it.
Crystal clear.
Perfect. So my name is Andrea Stella. I'm Vice President for Research and Development in Marelli Automotive Lighting. And I want to give you a short, really short, because 6 minutes are really short, insight of the automotive exterior lighting from a set maker point of view. So first of all, a couple of words about the company. Automotive Lighting, Marelli Automotive Lighting is a company which starts as a joint venture between two big component suppliers in automotive, Magneti Marelli and Bosch in 1999, and going through several acquisitions and evolutions, ended up in 2019 merging with Calsonic Kansei and becoming one of the biggest automotive component suppliers in the industry. As a matter of fact, this is our portfolio of products, of which automotive lighting is one of the biggest business lines. We are a truly global company with a footprint which is really covering all the continents. And Marelli, the whole group, is a company with 13.4 billion euros of turnover, 170 locations worldwide, and over 60,000 employees, of which Marelli Automotive Lighting is taking the second position in terms of rear lighting supplier and third position in terms of front lighting supplier in the whole automotive exterior market, with a 3.6 billion euros turnover, 31 locations and 20,000 employees, more than 20,000 employees, of which about 2,000 in the R&D group in my team. Our product portfolio is pretty wide. We go from headlamps, rear lamps, lighting, electronic, and also sensors. In the headlamp, we cover the full spread of technologies from halogen to our latest and greatest digital light. We will speak shortly about that later, where we have more than 1 million pixels to shape our light distribution and generate communication through projection on the road. Together with laser and traditional LED. We say traditional because LED now, since 12 years, is standard technology for exterior lighting. In the rear lamp area, we cover also there the full spread of technology. We go from full LED rear lamps to OLED rear lamps. Of course, here in the rear, the keyword is homogeneity, style, and design. Together with function, of course, but it plays a much bigger role in the styling of the vehicle. Lighting electronic is also part of our portfolio. We designed, produced all the LED drivers for our products and also for our competitors sometimes, up to the complicated controllers for digital mirror devices for the DLP applications that I mentioned before. And last but not least, we are also active in the sensor area for driving assistant and autonomous driving, where we also have a joint development agreement with the company Xenomatics in the LiDAR area. What is important for me to convey as a message today is the fact that all these innovations in the automotive lighting field are not possible with the set maker standalone. They need a strong partnership in both directions. First of all, with our customers, because our devices are deeper and deeper connected with the rest of the system and need a strong collaboration and co-development with our customers, but also with many of our tier 2 suppliers, because technologies like LEDs at the beginning of the 2000s and laser and then digital light processing are only possible for us if we have the right partners in the tier 2 area. So here we have some examples of what our history has seen, and it is part of our history being the first in the market with the most innovative technologies. We go from 2008 with the first full LED headlamp in partnership with Audi and Philips Lumileds. We like to say we were the first. There is another one who says also claiming that we are the first. But with Audi and OSRAM, we pretend to be the first in the laser converted light into front lighting, and we are definitely the first we were definitely the first in 2018 with the first micro mirror headlamp with 1.3 million pixels in the Maybach S-Class, and immediately followed by the Audi e-tron, where similar technology is also applied. So message here. Without partners, we cannot introduce innovation in exterior lighting in automotive. So just the last slide, because I think I have 1 minute left, which wants to be also a proposition for further discussion in this meeting. What are the micro trends that we as a set maker see in the automotive lighting industry? So styling and performance are always played a big role in terms of trade-off between what is nice and what is useful, especially what is giving additional safety to us and to all the drivers. New functions are entering into the field. New signaling functions in particular are related to autonomous driving and car status signaling. This is a new field. Sensors for driving assistance and autonomous driving, which could be integrated in our lighting components, which are sitting strategically in the 4 corners of the vehicle where the best angle field of view can be provided, but also optimizing through our lighting and our light emission the performance of the other sensors which are assembled somewhere else in the car, such as cameras, for instance. And then because of electrification, energy saving, and so on, our system must become smaller, lighter, however efficient, but more and more complicated. Bringing on the market a 1.3 million pixel for light projection on the road requires heavy effort of system integration together with our car makers. And last but not the least, digitalization, as I just mentioned, introducing new communication functions and a very strong increase of software content into our products and into the system. So I am 35 seconds late. I hope we can catch up, but now it's open for you to questions.
Excellent. This is an excellent talk, and thank you so much for being open to collaborations and partnership. That's all what this meeting is about. I see that Jose has a question already. And Anka. I see a lot of people who have a question.
Let's go first to Anka, of course.
Yeah. Go ahead, Anka. Please unmute.
Sorry, yeah. Sorry, yes, I have a question about the digitalization, in fact, because you mentioned as well some, I think some digital light in the headlamps. Do you mean that you put the intelligence inside the headlamps, or you have as well some intelligence in other places in the car or outside the car? How do you deal with the intelligence in the car?
The intelligence is distributed, and it's also depending from the car maker platform strategy that they have for the vehicle. But definitely the headlamp itself cannot fulfill all the functions. It needs information coming from other sensors, navigation system, or body control units that are needed to generate the light distribution on the road. So depending from also the car architecture, the system architecture strategy, we have developed systems where we have a heavy content of intelligence in terms of real-time rendering for the light distributions in the headlamps. This we have done, but in other applications with similar technologies, we have just received this pre-processed information from the vehicle architecture. So this is very, very car architecture dependent, because these systems, as I said before, are much deeply integrated with the whole vehicle system.
Okay. Thank you.
You're welcome.
Yes, Sana, from the YouTube universe, as I said before, we are broadcasting this in YouTube, and there's a company called Sun Microsystems. My very good friend Farsad Parsaye has a question. How deep do you dive into the LiDAR and its component development? Do you consider LiDAR given as a black box?
No, LiDAR is a technology that, of course, needs a partnership to be developed, because LiDAR, we cannot afford to go through the learning curve of such complicated technology by ourselves, because we will be late in the market. So we are actually working in partnership, and we don't work in a partnership with the black box approach, because especially when we look at the integration of LiDAR into our devices, we need to know, for instance, what the outer lens is doing to the laser arrays that are actually used by the LiDAR to collect the information from the road. So we want to have a deep knowledge of the system, but working with partnership with those who have made the learning curve about this technology much earlier than we did.
Andrea, I hope you are ready, because that was the perfect answer. Many companies in EPIC develop LiDAR solutions. I'm going to introduce you to many of them who are really already asking to talk to you. But I have a question here from a beautiful company in the UK, Surrey Nanosystems. How are you today?
I'm good, thanks, Jose. Andrea, I have a question. You said that there's a trend to become much smaller and complex in terms of size and functionality. So what do you think, what are the biggest challenges in this direction?
One of the biggest challenges, and here we speak about optics per se, is reducing the size of the optical system and keeping a decent efficiency. This is probably one of the biggest challenges we are facing in the light industry, because of the style wishes of the designers, but also because of the availability of space for us in the vehicle. And I guess that I'm pretty sure that when more sensors will be introduced in the vehicle, in the four corners, as I said before, which are strategically positioned, there will be less and less space available for the traditional lighting functions that I believe will remain, maybe with a different purpose, but this will challenge a lot the efficiency of the optical systems.
We will speak also about that. I think we have more questions from YouTube. Would you like to ask them now, Jose?
Yes, I was expecting that when Andrea was looking for partners in LiDAR. Yeah. So we have a company in EPIC, Hamamatsu. My very good friend Scott Barry is wondering, the R&D in optical sensors in LiDAR, is this happening always in the UK, or are there other locations for R&D?
No, actually, we are not located in the UK. We are located, our headquarters for front lighting is in Germany, where I actually sit, is in Reutlingen in South Germany. And for rear lamps, our competence center is in Tolmezzo in the northeast of Italy, where, by the way, I come from. And so these are the two locations, together with a team of engineers in Italy, in Turin. So Tolmezzo Turin and Reutlingen are the two locations where we develop this technology.
have one more question. They ask, how does Marelli see the market for LED matrix headlamps by 2025 in terms of adoption?
Okay, this nobody has the crystal ball, but I would say that for what concerns the European market, I see this democratization of the glare-free high beam or matrix systems, whatever you want to call it, or ADB. Everyone has his own exotic name. Becoming definitely going deeper into the car segments down to the A segment. So most of the vehicles will have it. The question is what's going to happen in the US, where a regulation we're waiting since many years that would allow that, but they're still not updated. And China, I think, also is on the same path. So I guess that this will, probably in 2025, if we exclude the effects of autonomous driving, probably we will not speak anymore about low beam or high beam. We will speak just about a proper light distribution that we need in any moment.
So I have a person who would like to introduce you because Rolando Ferrini is leading the R&D to prototype and production activities in MicroOptics, including automotive lighting. Rolando, do you think there is something we can do together with Marelli on this?
Absolutely. Thank you, Jose. So I was really listening with a lot of interest, the talk of Andrea. Just to introduce myself, I'm leading the activities in micro-nano optics at CSM, which is an RTO in Switzerland. Originally, I'm Italian, and I know Magneti Marelli very well because I was studying in Pavia, where, let's say, Magneti Marelli was established a few years ago still. And since January, I'm leading the building of a European pilot line for freeform micro-optics. And we have actually automotive lighting among our end users. This is not a secret. We have Hella on board, but we are willing to have more and more future customers in the automotive lighting. I was triggered by some keywords like new functions, smaller, lighter, and efficient. It's everything that MicroOptics can provide. So I think it would be very interesting to connect, because in the second part of the project, we will have what we call pilot cases. So we will ask companies in Europe in several markets, including automotive lighting, to come to us and propose prototyping or up to small or piloting production of freeform micro-optical components for their products. So the question of Jose is always what I can do for you, what you can do for me. What I can do for you, I can bring to you a full pilot line, a full value chain that can produce components. We have on board companies that do this on a daily basis. What you can do for me, you can tell me wherever you see space for micro-optics in automotive lighting.
Thank you so much, Rolando. So EPIC is, as he said, maybe involved in this fabulous pilot line. And to reach out to Andrea or to Rolando, you can write as an email, and particularly to Andrea, you can write Jose an email. Jose will leave his email in the chat channel, and you can reach out and you can ask more questions as well. So the next talk is by OSRAM Continental, and we have Claus. Claus? You can unmute, and we will be very happy to hear your talk now.
Yeah, hello.
Excellent.
Thank you. Hello, everybody. I think you should be able to see my screen now, hopefully.
Yes.
Yeah.
So, very good.
It is working. Okay. Well, so yeah, my name is Claus Allgeier. I'm working about strategy at OSRAM Continental, and it is great that I have the opportunity to present OSRAM Continental to the EPIC community and hopefully get into some exchange, because OSRAM Continental is a quite young company. We will celebrate our second anniversary on July 1st. And on the other side, it's let's say it's founded on two strong partners, as the name say, OSRAM and Continental. So we still have a lot of expertise in lighting for automotive. We have 16 locations worldwide in United States, Europe, and Asia. and about 1,500 employees. And the idea behind OSRAM Continental is to increase the innovation of intelligent lighting for automotive. And what do we mean by that? I mean, just a sketch of a car architecture, which is, let's say, typical for high resolution HD lighting modules. And as you see here, there's different inputs, internal inputs, external inputs, which are available. So internal is typically camera, radar, other sensors. External is map, navigation data, GPS, and even via connectivity, so internet crowdsourcing of available data from other cars experience certain road conditions. And with all these information available in the data, you can take with a algorithm control unit, and you can calculate by that, let's say, the optimum light distribution, which is to be put on the road to be experienced by the driver and help him, of course, by driving at night. And this is then transferred to the light control unit, which then steers and controls what we call lighting modules. This is really where the light is generated. And here it's just for high definition, let's say, example, really high resolution light. And that's what it is about intelligent lighting. So it's a combination of lighting algorithms, software, light control units, and lighting modules. And that is what we offer to our customers: modules, electronics, and systems. And our customers are typically car makers and headlamp and rear lamp manufacturers. And that we do specifically for certain application areas, for front lighting, but as well for projection around the car, and also interior lighting. And now to speak a little bit about technology, in front lighting, of course, besides, let's say, more state-of-the-art materials and technologies we use to generate high beam, low beam lighting, or let's say lower resolution driving beams, we are in particular interested and use technology, two major technologies, which are able to generate high resolution lighting. And by that, being able to mask oncoming or preceding traffic, and even generating lines, patterns, or symbols, as was already shown by Andrea in the presentation before. And these two technologies, which are basic technologies, are on one side digital mirror devices, which are lit by LEDs, and these are able to make light distributions of about up to 1 million pixels, and that's also then the resolution. And as well, we use active matrix, micromatrix LEDs, which light by themselves and do pixels resolutions up to several 10,000s. And these both technologies somehow competing, but also somehow are able to be used for different use cases. This is something we are really working on and use it and are interested in further progress. And that is also what we see, and other solutions we also take for projection around the car. For example, here you see a use case is styling individualization, logo projection can be goodbye and welcome scenarios and individualization. And another important use case, maybe more future oriented, is to use these projections for traffic safety. For instance, to project turn indicators on the road to give pedestrians and bicycle riders the possibility to even recognize earlier in which direction the car is driving. And that in turn might become even more important in the future for autonomous driving. And here, in particular, technology of MicroOptics gains more and more importance, in particular microlens arrays. And yeah, and same technology we also use for interior lighting. These are for directly illuminating optical elements or also for projection on surfaces in window. And that now I come to the questions I learned in the EPIC typically are asked, and I put 2 slides together to guide through that. Is what can OSRAM Continental offer to their customers, or is offering to the customer and brings on the table. This is just our capabilities at a glance. So all these capabilities we use, of course, to produce the products by ourselves in-house. For example, with advanced surface mount technology, micro and macro assembly. We also do our silicon optics by ourselves. And all that we do to tailor our solution towards the specification of our customers. And that means this is exactly what we also in general are looking for. Of course, we want to improve these capabilities and everything, all technologies which help us to serve our applications, improve performance, reduce cost, are of high interest. And of course, prerequisite is automotive quality. And here's a few selected examples out of many, but I mentioned some of them. We are in particular interested for light modulators like DMD, but also for alternative technologies which are able to have high resolution and their higher optical efficiency, and of course cost is always a topic. Micromatrix LEDs for high resolution. I mentioned MicroOptics gets more and more importance, and for example, micro lens arrays is a hot topic. And for interior smart RGB LEDs, in particular with extension to mid and high power. So that are some examples. There's more, but thank you for your attention. So
thank you very much for a great presentation. As you would be expecting, there's a lot of people who want to ask you many things, because it's your first ever EPIC presentation and you already know the story. What can you do for them? What can they do for us? So the first question goes all the way to my friend Jordi from from my friend Jordi from Mind Optoelectronics. Jordi, it's your first ever EPIC meeting. Welcome to EPIC. What's your question?
Thank you. I don't know. Can you listen to me? Yeah?
We can hear you. A bit quiet, but we can hear you.
Right. Maybe this microphone sometimes
better.
Better. Okay. Well, yes, it's my first meeting in EPIC. We are a company that is Mind Optoelectronics. We are just a new company from China. And well, currently I'm stuck in Europe, so I'm preparing this CET time to join this meeting. So it's quite useful for me and for our company to profit these kind of meetings. And I really appreciate that you are doing these meetings from EPIC. I didn't know right now until 1 week ago that you were organizing this. So well, I wish you all my best for you, and hopefully you continue. Okay.
Thank you, Jordi. You got a question for Claus, right?
Yeah, well, we got a question because from my side, we wanted to know a little bit more about the micro LEDs roadmap technology, especially for headlamps. To Claus, I know that maybe is a hot topic as well, and everybody wants to know a little bit more about this since it's a little bit new technology. So, well, just let him explain a little bit more about that. Thank you.
So in particular about the micro LED roadmap itself, let's say I'm not able to talk because we do not produce micro LEDs at OSRAM Continental, right? This is one of our mother companies. OSRAM, for example, is in that field, and there's other suppliers. So I'm not the right person, honestly, to talk about the micro LEDs roadmap and there. I mean, I only can talk about it from a module point of view and from a let's say application point of view. And this is for sure that micro LEDs, as they develop further and really gives the opportunity to have a quite high optical efficiency, is something of a high interest. And as I said, so somehow two competing technologies at the moment, which is digital mirror devices and micro LEDs. But I think both will find their place or have already found their place. And so it's going to be interesting also for me to see how the roadmap really evolves in micro LEDs. And that's
fantastic, because on the 5th of June at 3 p.m. Central European Time, Epic Online Technology Meeting on micro LEDs with companies like Alos, Micledi, Aledia. Do not miss it. We have one more question, with 3 more questions. The first one is from Ralph Noll, which is the most beautiful background I've ever seen in Zoom. Ralph, what's your question?
Yeah, can you hear me? Thank you very much. Yeah, I represent in Optec, and we are actually a startup. We have 8 patents in 10 countries for anti-glare systems. The idea is pretty old. It stems from the 60s. It has to do with modulated headlights and a modulated visor. But we brought the whole technology to the next level. And we made some tests with RGB headlights to fine-tune the color temperature. As you might know, people at night are very blue sensitive. It's called the Pochinje effect. And we have seen lamps, they go up to 8,000 kelvins. It's really annoying for those drivers who come towards you. And we have developed something where you can set or fine-tune the color temperature. So my question is twofold. One is if you do any R&D on RGB headlamps for whatever reason, and secondly, we are looking for R&D test partners, and maybe we can have a chat afterwards to see what we could do together.
Yeah. Okay. Yeah. Thank you for that. That's interesting. I mean, to be very specific, RGB headlamps we do not at this point of stage investigate, but I think it would be interesting because, as you just said, of course the color tuning or something like that is something we do not do today, right? Every light module has a certain color temperature, and that's it. Of course, the question is how efficient you can do it, but so it would be interesting to get more information about what you do.
And we'll make an introduction so you can work together. We have one more question. It's coming from Alexander from Northern Cars. Alex, yes.
Thank you. You can hear me?
Yeah.
Yes. So at Northern Cars and Concepts, we are a headlamp and also small lamp supplier for off-road, caravan, and also defense applications. We are wondering about one specific product that OSRAM Conti have been advertising a lot, but I could not find it in your presentation, which are the exchangeable light sources, the OSRAM XLS, and also particularly the retrofits based on same technology. Do you have an idea about the roadmap for this product, or where you are headed, and why you did not include this interesting technology in your presentation? Thank you.
Yeah. Okay. Yeah, I mean, it's very simple. I mean, this is a product which remained in our mother company, OSRAM. So all kind of retrofits and also what you mentioned, the XLS exchangeable light module remained in OSRAM, in the OSRAM company, because this is more like a component, and OSRAM Continental is more dealing really with systems. Yeah. So that's the reason why it's not in my presentation. I agree, it's interesting products. And I'm not aware in detail about the roadmap, but if we contact, I can make a contact to the colleagues from OSRAM who certainly are, will.
In a meeting like this,
much appreciated.
The connections can be made on spot, live, because actually we have a person from OSRAM Optro in the room. Let me give you the microphone, because I think Grosz from OSRAM is with us today, right?
That's true, yeah.
Could you like to comment on this?
Actually, yeah, there is various flavors in how to do the LEDs for the headlamps. And one idea is to have them replaceable. And this is a newer idea, I would say, which has been proposed to the market for a few years. And as Andrea mentioned in the beginning, LEDs are in automotive headlamps for more than 12 years now. And what we find today is, for the majority of the cases, are fixed installed LEDs in the lamps. And to one part of the story, the reliability of the LED is in such a good way that it can stay in the lamp for the whole vehicle lifetime.
I hope that you are satisfied with the question, Alex. Klaus, one of the things that the purpose of this meeting is about is to connect you with my friends as well. And there's a company, Axetris, that makes fantastic micro-optics. And I think many of us have actually noticed your interest in macro arrays for projection. So I would like you to meet my friends from Axetris. Hello, how are you doing today?
Hello, everyone. Thank you, Jose, for connecting us. Yes, in fact, I had Andrea and Klaus the question, but I want to do at the end of the show because that was not just one person. So Axetris, we are a high quality, high volume micro-optics manufacturer for refractive and diffractive optical elements. And we are why we are here today is, in fact, we are very strong, as Jose mentioned, in telecommunication and other markets, but we have a diversification plan for automotive. And my question is, how do you see the outlook for micro-optics in automotive lighting or automotive illumination or automotive LiDAR market? That's my question. Maybe difficult question.
Maybe can you repeat? I somehow did not.
So my question is, how do you see outlook for micro-optics in automotive lighting or 3D sensing business in next few years?
Okay. Micropixel. Yeah, I mean it really depends for which application it is. In particular, in projection, the key area is to do not only static projection but also semi-dynamic or even dynamic projection, right? So everything which is able to do semi-dynamics or even kind of, let's say, projection for videos, finally, this is of high interest for us. So if that can be done and there's a roadmap toward that, I think this has a good chance to enter the automotive industry. But of course, you know, I mean, automotive requirements are typically quite tough. Yeah. So from quality point of view, so it could be also take some time to be able to fulfill these. Yeah.
You know, Klaus, micro-optics are booming in Europe. So companies like Axetris, like SUS Micro-Optics, Morphotonics, this is the micro-optics revolution that we're starting. So you're looking for any shaping of light for lighting, don't look any further than Europe. It's really happening now. And we're going to move to the next part of the meeting. This is the amazing part of the meeting. 3 car makers back to back. We're going to have Audi, Volvo, and Renault to talk about their supply chain and their challenges. So we start with Audi, and it's such an honor to have Stephan Berlitz with us this afternoon. Stephan, thank you very much for joining and for telling us how we can help you. The floor and the attention of everyone is yours.
Yeah, thanks a lot. Warm welcome. I have to see just.
One of the things that we're going to, well, I think is working now, is working perfectly. Did you go to presentation mode?
Okay, presentation mode, Silo.
I think it's happening. No, it's not. I think you might be sharing the wrong screen. I think, do you have 2 screens?
Yeah, just a moment now.
No, it's happening. The floor is yours.
It's happening. Okay. Okay, thanks. Yes, so I'm just concentrating on one point of future lighting technologies, because I also was asked, could you tell something about your roadmap and strategy about micro LEDs? And as we heard before, micro LEDs seems to be a very, very interesting point for a lot of people. And we are thinking a bit further, even to say, okay, micro LEDs for the future for communication light. So what is it? It's where we say something maybe integrated into plastics, maybe integrated into the glass. And there are a lot of things where we think we could use these communication lights in the future. And one thing is, of course, if we use it in the front, we can use it then for communication with pedestrians. And for example, at the crosswalk, it's not only like we have with this digital matrix light where we have then projections on the road. It's even more on the car that we say, okay, we need something on the car where we can communicate with others. And there's also maybe for cars where we say, okay, maybe in the future we have car-to-car communication, but at the moment we have a lot of cars that are not able to have this car-to-car communications, and there's millions of cars that we have on the road at the moment. And you also have to communicate in the future with this, I would say, old cars that we sell today. And so we need then also for them some warning or informations about what the car is doing, what's happening all around. And last but not least, also maybe we have to indicate what our automated driving car is doing now, what the car will do in the future, because there's no driver, actually no real driver inside. So the communication to others has to come then from the car itself, not only from the driver. And all these things, of course, we don't only need on the front, we also need it even more maybe on the side, because if you think about city situations, it's mainly you see the car from the side, because if it passes, or if you go, I would say, vertical to the car. And also, of course, in the rear, if you follow a car, that you can see, okay, what's the intention of the car, and even to get what we are thinking about, some sort of predictive warnings that we say, okay, in the future, we will tell the other cars behind us about something that we already know from our car to infrastructure things, that we know, okay, there's a traffic jam in front of us. We know that there's an icy situation in front of us, but we also can tell this to the cars behind of us so that they get this information, so that they, yes, we have connected cars, and we could still yes, some sort of a social function, provide this information then to others that are behind of us. And for all of these things, of course, that are useful, it's that we could use it also for styling. As you can see on the pictures on the right side, it also looks quite interesting. So you even can use this for, I would say, differentiating styling ideas for the future, that you could personalize or yes, make it more individual or something like this in the future. So some sort of I would say just a technical roadmap, I think. For the future, we think that, of course, this real small micro LEDs is something for the future, but what we want at the moment is actually more some sort of display with maybe, I would say, mini LEDs or something like this, that where we could start, where we could say, okay, we have some sort of easy displays, maybe in red, maybe in white, maybe in the future in RGB, to communicate, where we have then the area, I would say, in the front light or below the front light or something where we could give some informations. And of course, in the future, we would like to have a bit more resolution for this. And then furthermore, in the future, we would like to have this micro LEDs and maybe even, yes, being part of our windows, maybe on the side, maybe on the rear. And maybe then also in the very few future scenario, then something where we can put these LEDs on the complete car body. On the right upside, it's a picture from Valio that I've seen these days. It's on a camping trailer that you can see backwards through the car, or in this view through the trailer. And that could be something that could be possible then in the future with these things. And we also had something shown on the CES last year in Vegas, where we showed them this light urban experience. That was actually a car. It was a 1-to-2 model, where our styling guys showed how they could imagine how this communication could work if we put all the LEDs or some lighting on the complete car, and how we could make then some sort of different informations, communication, and all of this. And this idea was that it was completely interactive. It was reacting. It could give symbols, and you could actually interact with this car, and the car could show you that it's recognizing you. That was really interesting. In this case, we used projectors, but actually in the future, we would like to have some micro LEDs for this full communication display on the car. And you could even imagine that it's possible to do something like this, because if you had to think about automated driving cars, the driver has actually no need to look outside the car. So we could use all the windows then if the driver is not driving itself as a real big display. And that was actually the vision behind this. And yes, I think it's a long roadmap to get this solution, but it's something that we would like to start now. So thank you.
Thank you so much, Stephan, for this futuristic car. It looks like a dream car, super beautiful. So you know how it goes with Epic. You tell us what you can do, and you leave room to hear what can the others do for you. What kind of collaborations are you looking for? What kind of partners are you looking for?
Actually, it's altogether. It's first thing is of course to show then everybody, okay, what could be the future direction. That's one point. That's the main reason why I'm here. And of course, I need a lot of partners, because it's this is a complete system. Actually, it's a complete system. You need electronics, you need lighting, you need actually even some old-fashioned characteristical hardware like this Windows. So it's nothing to do with lighting or nothing to do with electronics, but it's you also need actually a new production of glass, for example. And it's actually to see, okay, who is working on this field, what are the different ideas that we could get, and actually to work together to see then, okay, what could be then the first steps to get, of course, micro LEDs, MicroOptics, new electronics, flexible electronics, and all of these things. It's something that we will need. And also, of course, the electronic control units for all of this, because it's a difference if you turn on one LED, 5 LEDs, or like this, a few thousand, or even maybe one day a few million LEDs. So you need some sort of like a display controller, actually, but in fully 3D and yes, for automotive outside technology, actually, not only for the interior.
I see, maybe even artificial intelligence to know which one that should be working at where.
Yes,
at what
of course. Yeah.
That's excellent. Just let me remind everybody that we at Epic, we are aware of how important the micro LED field is getting, and there will be an online technology meeting on the 5th of June for micro LEDs and technology and applications, and there will be also an event organized by Epic in December in Grenoble at CEA Leti, Epic meeting on micro LEDs at CEA Leti. That will be 15 to 16 December 2020. So maybe soon you will be receiving emails for invitations that you know how important this meeting will be. Do you have questions to the audience? Do you have questions for our speaker? Jose, do you have something online?
Well, I have my very good friend Christopher from SUS MicroOptics raising his hand. Chris.
Oh, hi. Yes, thank you. First, I'd like to introduce SUS MicroOptics. Maybe most of you know it, but I just start again. So we're doing micro-optics and we're doing the whole chain. So we can do simulation, we can do optical design, and we are producing prototypes and also series production. So there are some light carpets which are made from micro-optics, and we produce more than 1 million pieces per year of this. And so my question goes, so you have displays on the car, but how do you see the projection? So I know you got some DMD headlights, you want to project something in front of the car. How is it with turn indicator and stuff like this? What is your vision over there?
Yeah, that's actually not more on vision. It's something where we are concretely working on, of course.
Yes.
So we started with a digital matrix light, of course, for the front, and yes, you need this. You have this complete projection area around the car, and we should use this complete area around the car for projections. And the only negative about projections is it only works during nighttime. And so this micro LEDs and something for the future, then also to have all this communication also on the daytime on the car. And that's actually then where we say that's why it's more in the future. And what you told about this projection all around the car is of course something where we are concretely developing at the moment and try to get as much as possible projection systems in the car, I would say. And even if possible, yes, completely adaptive, not only stable, just not only a static thing, but maybe also more reactive, so that because communication is not only giving a signal, communication is even easier if you have some sort of a movie, and the best is if it's an interactive movie, something like this, then the communication is the easiest. It's like we have it between humans. It's written conversation is good, but takes a time, and if you show some images, movies, then it's working much faster.
Thank you. I would like to hear from Seoul MicroOptics. Oliver.
Hi, yeah, we are Seoul Semiconductor and we are doing LEDs. I have seen some mixing between optics and electronics. Hope you can hear me well.
Yes.
My name is Oliver. I'm heading the automotive team of Seoul Semiconductor in Europe. And I just would, maybe you know that Seoul has demonstrated at the CES RGB LEDs for displays, so for consumer electronics, for 200-inch displays and more. And we are actually looking how we can do this also for automotive. So especially RGB for interior can be something, but I'm also seeing now that we are looking to kind of not only red and white kind of things outside, but also some kind of colors. Yeah, it would be an interesting field that we can work together with the automotive industry. Depending on, of course, the time scale. I think today white is not, white and red are the ones that you can show outside. But if you go for colors, there needs to be some regulations. But I think that will not happen today or tomorrow. It will happen maybe in a couple of years. And therefore, I think it's the right time to start to collaborate, because automotive has, of course, different requirements than general lighting or displays, right? So that's always a little bit more tougher to get into a car than into a display in MediaMarkt.
Thank you so much, Oliver. So if we don't have other questions, so when we say LEDs, there is power, and we say power consumption, there is a lot of stories coming with that. That's why we're very happy to have the next talk from Paul-Henri from Volvocars. Paul, how are you doing?
Yes, fine, thank you.
How do you find the meeting so far?
Yes, it is very interesting. Yeah.
Yeah, we're looking forward to your talk.
Yeah.
Yeah, we can see now you're sharing the screen. You could just, excellent.
Yeah, do you see my screen? Yeah, so I will speak about lighting, and especially I will focus on sustainability. Yeah. So why? Because I think we have to reduce the pollution. And so I could speak about plastic and so on, but I will try to focus on consumption, because consumption for European car makers is a key issue, especially this year, because we have a new regulation in Europe. Perhaps you are not aware of it, but you will see what I put in the presentation. But we have a new regulation and we have a new homologation cycle for all the car makers. And in this new homologation cycle, we have to respect a threshold. And this threshold was defined, and it is a 95 grams CO2 per car. And if we are above this threshold, we will have to pay penalty. So this penalty will be 100 € per car and per gram CO2. So you can see on the right, I put a schematic. So it was an analysis of Jato company in 2018 about the penalty that perhaps the car makers will pay in 2020. And you can see that it can be a huge penalty. And due to that, the car makers try to do something, and especially they will develop the electrical vehicle or hybrid electrical vehicle to reduce the power consumption and then to be able to respect this threshold. But when we see this cycle, what is the relation with lighting? In this homologation cycle, indeed, the lighting is on, especially the daytime running light. And the daytime running light, it is what we use to do the signature of the car with our beautiful signature. And also the car makers, because it is only homologation in daytime, they can have a bonus, what we call an eco-innovation, and they can have this bonus if the low beam consumption will be below 30 watts, something like this. And in parallel, we have discussion now with the European Commission, and in 2025, we could have also a new homologation cycle, and in this new homologation cycle, we will have also a night time. So low beam will count in the homologation cycle. So what is the problem? So the problem is when we compare CO2 consumption and power, we could say that for a standard car, so what we call an internal combustion engine, so 1 gram CO2 is related to 50 watt power consumption. And if we discuss about electrical car, we can see that the battery size, when it is an hybrid car, it is between 10 and 15 kilowatt hours. And when it is a full electrical car, the battery size is between 50 and 80 kilowatt hours. So what does it mean? If we see what we use for optical concept, I put a slide from Driving Video News where you see what are the optical concepts we use in automotive industry. You can see that it is a very old technical concept. So we have reflector design, we have light guide design, and so on. And this efficiency is quite low. So if we see, for example, for a DRL function, I put different technical solution. So I compare with bulb. So when we have a bulb, if you want to do this daytime running light, so you can see on the left with Dacia Duster, the consumption was around 50 watt per car. So 50 watt per car, it is 1 gram CO2. And if you remember the previous slide, the threshold is 95 grams CO2. That is to say that lighting is around 1% of the total consumption of the car in the homologation cycle. So it is important. Also, if you compare to battery, you could say, I have battery, I don't care about power consumption, but no, you take care also, because if you have a battery with a hybrid vehicle, it will be 0.5% of the autonomy of the battery, for example. So when you have LEDs, so you think that when you have LEDs, the power consumption will be reduced, because we have reduced it in our house, for example, with LEDs. So you can see a LED solution with reflector solution. And then we have reduced the power consumption because optical efficiency was quite good. And so we can have a solution with between 10 and 20 watts. But when you see on the right picture, it is what we have now when we do some signature on the car, like a Volvo signatures, for example, the torse hammer, and you see that we use an optical solution, what we call light guide or edge light technology. And in this solution, the power consumption is quite important. And sometimes it is more important than bulb. So even if we have LEDs, so we have power consumption bigger than bulb. And then it is very important for the consumption of the total car and the autonomy of the battery. If I continue, I put an example on the low beam. So low beam, it is when you drive by night, you switch on the low beam. So if you see what we have was bulb in the past, it was 150 watt per car. That is to say that it is 3 grams CO2. And it could be, if you have an hybrid car, 1.5% of the autonomy of the battery. If you use a LED solution, so you have different optical concepts and you have different performance. So I put a medium car like Renault Captur, for example, or it could be Volkswagen Polo. Also, you can see that the optical system is LED reflector. And in this case, optical efficiency is quite good, 50% we can say, and the power consumption will be good. But if you begin to reduce the size of the function and you want to have also a very good lighting performance, in this case, the power consumption will increase and will increase a lot. So you can see a Volvo solution, for example, the height of the function is between 20 and 40 millimeters. So you can see that optical efficiency is quite low, between 20 and 30%. And then the power consumption is important. So it could be around 2 grams CO2. So that is to say that when we speak about power consumption and autonomy of the battery and the penalty we will have in Europe in 2020, lighting is impacted. And so about photonic community, we have to develop new technical solutions. So you can contact us if you have some good ideas to have very slim lamp, very efficient optical solution, very efficient electronic solution also to drive LED, to be able to reduce the consumption of the system and also to be able to avoid to increase the size of the battery. So if you want to do this, you can contact us, you can contact all the car makers, and you can contact all the lighting suppliers like OSRAM Conti, like Marelli and Valeo, because they are aware of this technology, and we have to develop new optical concept, because today what we use is not so new. It is old technology developed by 10, 20 years ago. Thank you.
Thank you, Paul, for a great presentation. I think it's really, really great that you told us that this was your challenge. We had a call with Paul like 1 week ago. He said, we can talk about LEDs, we can talk about optics, but really what concerns me is the power consumption, and I want to share that with the community. We have some questions in the room. I'm going to give first to Eneka from Eneka Consulting. What's in your mind?
Yes, Paul-Henri. In fact, I have one suggestion for the lighting and one question for the powertrain, in fact. For the headlamps, in fact, I think we talked a little bit before about integration, but we didn't precise what is this kind of integration. And I think one of the trend is to go to monolithic integration. That means integration of photonics and microelectronics function on the same wafer. That's one point. And the other point, and as well the same different function on the same wafer. We talked about LiDAR or SSL, and you can really integrate everything into the same wafer if you go to monolithic integration. So that's one point. It depends, in fact, of the power that you need for your lighting and so on. But if you go to that, and as well, you reduce the complexity. And the other point is, of course, the freeform optics, because you will reduce the number of optics, of micro-optics inside the headlamp. So that's the point on integration in the headlamp. And the other question I have, in fact, it's a very new investigation that I have in mind, because I talked previously with the CTO of Valeo Powertrain, and I think, in fact, my question was, where is the photonic inside the powertrain? And he told me about the precision sensors, but as well, we talk a lot about how to reduce in fact, most of the mass and of the cost is just to cool the powertrain. And really what could be explored is to change of technology, and maybe to put some optics inside the powertrain, in fact, in order to go a step further on the consumption reduction. And for this, I think we have to go to some spatial technology or defense and security technologies. And by similarity, I think there is really an axis of development for automotive. So that's just a very future trends, but I think really there is a full set of possibilities and capabilities impacts of photonics on that point. And I think it's a very important point, in fact.
Yes, you're right. So I'm not a specialist in powertrain, but for example, in lighting, we use some sensor in the chassis to be able to know the pitch angle of the car, and we use mechanical sensor. So if we can have some optical sensor, it could be a very good thing, and it will be simpler also for the chassis people and powertrain people. Yeah. And if we discuss, if I come back to the first question about SSL and monolithic solutions, so this seems to be a very good solution. but we have seen that it is not so easy to develop this monolithic solution, especially when we have a lot of pixel. And then when we begin to have a lot of pixel, because it is quite small and we need to have high power, at the end we have 50 watts to develop a micro LED solution, something like this. So it is not so efficient. So we have to see how we can reduce the power consumption also on this monolithic solution.
Okay.
Paul, I'm going to introduce you to some more people who are joining the meeting today. I'm going to go to the very south of Spain, Andalusia. I'm going to give the floor to Rafael. Please tell us why you came to this meeting. Tell us about the work that you're doing in plastics at Tech, and maybe find out how you can help Volvo with the power consumption.
Okay, good afternoon. I'm Rafael González. I'm working in Tech. Tech is in the south of Spain. Can you hear me well? Okay. In the south of Spain, we are quite, Tech is a technological plastic center. So we are quite good regarding plastics and raw materials. And we are now, as we are close nearly to Valeo Martos, we are quite, we have quite expertise regarding lighting, real and headlamp. We are now currently working mostly with LEDs, and we can develop a complete project regarding lighting for headlamp and real lamp, from the design to the optic simulation, optic measurement, KI simulation, labs, prototypes, electronic, and nearly everything. I will be glad to help you if you are able to contact us. Of course, I am here learning a lot of this afternoon, and I will be blessed to be able to help you in the future.
I think there's a lot of collaborations to be happening here. We have still 1 hour and a bit of meeting. Let's go to the next presentation. Let's go to one of my favorite cars. The car that I had, my first car was a Renault. The second car was a Volvo. They are both great. And we go to Renault now. What a great afternoon. Thank you very much for joining us. The floor and the attention of the full community and 300 people in YouTube is yours. Hello, I think we have lost a little bit of audio with you. Maybe you're still unmuted. Yeah, let me try to unmute you. You have to unmute yourself, otherwise we cannot hear you.
Yeah,
yes,
okay.
now. Yes, fantastic.
Perfect. So you will see my screen normally. It's okay for you?
Yes, it's perfect. The floor is yours.
Perfect. Okay, thanks. So as we have limited time, so I will just focus on 2 topics linked to automotive lighting. Okay, one linked to the affordability of systems, and the other one will be linked to intelligence of lighting systems. Okay, so so regarding affordability, we have done in the latest 5 years, we have with 3 generations of headlamps succeed to propose to the majority of our customers very efficient full LED headlamps with a good level of performance, and we have achieved this with a big effort on the standardization in order to limit the price of this type of equipment. So today we can offer from the B segment to the D segments full LED headlamps as a standard equipment. For example, on the new Clio 5, which was the first B segment car with full LED headlamp. But we have not finished this integration of LED technology in the full lineup. So we have to find additional breakthrough in the techniques in order to achieve more stringent economical targets. So for some global access cars, also for LCV vehicles also. So regarding this, we will need some simplification of systems, higher level of integration, and also a higher level of standardization of the LED headlamps. My second message was focused on intelligent lighting. Okay, so Renault will provide to customers ADB systems with matrix headlamps this year. This functionality is considered by us as a very interesting functions with a very huge value for the final customers. Okay, that's why we want to go a step further in the deployment of this functionality with the objective to find a way to provide this functionality for everybody. In order to provide this to everybody, as we have nearly done for a full LED headlamp, we need to also to look carefully all the cost of these systems in order to have a larger adoption of it. At the other end, we will need also to work on high definition systems, okay? And from Renault point of view, we will focus on micro LED solutions. And for us, we will need to go to a full horizontal field of view systems, which will imply a huge number of pixels in order to achieve this. So if we want to conclude my 2 points, if we look at the future of automotive lighting in Renault Group, we will need simplification, integration, and higher standardization of all the components, which leads to a final headlamps, so drivers for the light sources and for Morphotonics. Okay. We will have some opportunities in the future with new electrics architecture, which will give some possibility to integrate, for example, smart LEDs or new integrated circuits, which will be able to work directly with CAN-FD protocols or something like this. And we will have also another opportunity to work with software as product and not only hardware as a product with suppliers. Third point, to summarize, so the development of micro LED will be for Renault Group the target in terms of digital lighting, because we want to go to a very efficient solution. So regarding power consumption, as it was discussed just before by Paul-Henri. We want also to achieve this large field of view with these systems. And in order to have a good level of adoption of this technology, we will need also very affordable technical solution from suppliers. And just to finish, I have focused my speech today on front lighting, but we have also similar revolution, which is coming for internal lighting or external signalization. In these different functionalities, we will have more and more dynamic effects, RGBs, as it has been also discussed before, and it will lead to the introduction of hundreds or more LEDs, which can be RGB or monochromatic LEDs. So in order to achieve also this revolution, we'll need also smart systems and very affordable ones. So thank you for your attention.
Thank you so much. Thank you so much, François, for this nice talk. We hear now that you're open to collaborations and you're open to hear from all the participants here. That's very nice. That's very nice of you. I would like to know if we have among the participants here question for François. Otherwise, let me introduce to you from Fraunhofer IOF, member of EPIC, Kevin. How are you doing?
Fine, thanks.
So he's looking for research. I'm sure you can tell him something there.
Yeah, so the question Jose already asked is what we're looking for and what we can do. So maybe I answer this. What we are looking for is, of course, the needs from OEMs especially and tiers. What's the future of photonics in automotive lighting? What we can offer is, of course, basic knowledge or fundamental knowledge in micro and nano optics. Also freeform technologies from the basic design to system integration and final products. And to give some basic ideas, so we are involved in the light carpet development. And maybe something which is quite interesting in the future is our anti-reflection coating systems, especially if you think about power consumption, if we think about complex systems in the future, then I guess you need good coating solutions to really get the light where it has to be.
Thank you. Thank you so much. Yeah.
Welcome.
Okay. Thank you. I would like also to introduce from Johannem Institute, from Johannem Research Materials, Paul Hartmann. How are you doing, Paul?
Hi. Hi, Sam. Thanks. I'm fine. Well, very interesting talks up to now. And as you know, UNM Research is also part of the fabulous consortium working on micro-optics for different applications, among them automotive, of course. We try there to increase our knowledge in micro-optical solutions to increase the energy efficiency and also the size of different solutions. I have very flat freeform approaches. And I think today we have heard already in some talks that this is a quite promising avenue to go through. And I'm very convinced that we will find a lot of applications for this new technology, where we can offer now already some first answers for some solutions. I think, although the project still is in its infancy.
Thank you so much. So the project, again, is fabulous. This is a European pilot line, and Ronaldo, who's here, is the lead of this project with CSEM, and EPIC is responsible for the communication of this project. So whenever you have a question or you would like to reach out, please write us an email or to Jose, and we can make these connections for you. Thank you so much again, François, for the nice talk. Please allow me to go to our next speaker, also a member of EPIC from SABIC, Renzo.
Hello, can you hear me?
Yes, we can hear you. Thank you for joining us. So
My
now
pleasure.
You can start.
Yeah, I will share my screen right now.
Excellent. So now, very good.
Okay, very good. So, hello, everyone. My name is Renzo Falavigna. I work for SABIC, and I am a business developer for a specific product line. As you may know, SABIC is a plastic material producer, is a petrochemical company based in Saudi Arabia. And SABIC produces a wide range of products ranging from standard materials, let's say commodity materials like polyolefins, up to specialty performance polymers, like, for example, ULTEM, polyethylamide, and so on. So I come from the SABIC specialty side, so I'm taking care of specialty resins. Here you are an overview of the resin that we can propose. So starting from our best-in-class material, ULTEM. ULTEM is a polyethylamide, so highly transparent for high temperature applications. It was widely used for auto lighting in the past. Then we have Noril. Noril is a PPA resin, so it's mainly commercialized as a blend between PPE and polystyrene, but can also be polyphenylene oxide, PPE, plus polyamide. And it's well known because of the low density and high mechanical properties. Then we have a full range of compounds where we use our resin we produce, or we compound resin from other sources. So we don't produce, for example, internally polyamide, but we use polyamide in our LNP compounds. And then we have our Lexan resins that you most probably know. In the specialty side of SABIC, we sell and promote Lexan copolymers, so copolymers of polycarbonate. What can we offer for the automotive lighting applications? Well, let me focus a little bit on a couple of products. I already mentioned polycarbonate copolymers. So here you can see a couple of them, Lexan CXT and Lexan XHT. Those are copolymers where one of the monomers of the polycarbonate has been substituted with another monomers. And this change leads to an increase of the TG, glass transition of the polycarbonate. Playing a little bit with the chemistry, because we are synthesizing those resin, playing a little bit with the chemistry, we can increase the TG up to 190 degrees C. So these will meet high temperature requirements, for example, for the components very close to the heat dissipation of the LED lights. And as we know, automotive lighting are a kind of closed environment where the temperatures can rise quite a bit. The difference between the two technologies, it's about XHT is mainly non-transparent, opaque, while CXT is a fully transparent copolymer, natural color. This is what we can offer from the amorphous side. From the semi-crystalline side, as I mentioned you, we can produce tailor-made compounds based on all the resins available on the market. So let me mention you just a couple. So let me mention you our Verton family range. Verton are compounds based on long glass fiber reinforced. Are long glass fiber reinforced compound that can be used, for example, for mounting brackets of LED lights in automotive. Especially long glass fiber compounds can be useful in case you want to reduce vibration, and in case you need high fatigue and high creep. So, as a summary, what we can do for you, we can provide you materials. We can provide you materials for the following application. For in case of lenses and light guides, we can provide you Lexan CXT, transparent Lexan, or Lexan XHT, colorable. We can provide you for bezels and reflectors. Again, high temperature resins like Lexan XHT or Lexan CXT and Ultem resin that are really good in processability. They can be metallizable directly without any issue, and they have a very good Haze-on set according to the formulation. And then in the end, we have an LNP product line, so the compounds based on polyamide ranging from polypropylene to high-end polymers like PEEK for interior application, specific application in lighting, like for example, heat exchange. We can provide you thermal conductive plastics. And what we are looking for issues. We are looking to hear you complaining, because we are not only providing materials, but we are also providing solution. We are providing technical service, and we are providing simulation expertise, for example. That's it from my side. Thank you.
Thank you very much. And this is where I enjoy the meeting the most. This is when we heard from the end user system integrators, and now we had the companies trying to solve the issues. So what I normally do, if you follow this, is I go back to the car makers and tier ones, and I ask them, what did it resonate with you in this presentation? So I'm going to go to Claus, because from Continental, we need to understand what are the issues with reliability, and can the material that SABIC is making for any harsh environment solve any of those issues? Claus.
Yeah, I mean, it's of course interesting to hear what's possible, and I think from the information we really need to look into details and see what we can use, right? I mean, it's of course too early to be specific here, yeah? But it's good to see also opportunities and how to deal with that.
But do you have any demands when it gets very hot Imagine that we're in summer, every year is hotter in the world. Do we have any demands when the optics get very hot and you can use the unique selling point of SABIC plastics?
Yeah. I mean, it's not so much summer and hot. I mean, it's even, as was mentioned today, miniaturization is a key topic for the future. Everything gets smaller. Lenses, everything gets smaller. So temperature loading also from LEDs and everything, because of the miniaturization, is getting more important. So there might be possibility to use this high temperature parameters, and possibilities.
I'm going to go to my friend Stephan from Audi. The Audi A8 a few years ago was such a call for attention in new optics and photonics that there were market reports just explaining what components were in there, and I bought many of those. Stephan, are there any challenges when it comes to the reliability of the optics that perhaps high reliability material like SABIC can solve?
Actually, no. We had no problem with reliability, because that's something that we check in before. Actually, because for these new technologies, for example, we have cooling systems in our lights. So actually, it's not the big problem with the temperatures and all of this.
Give me one challenge, Stephan, one headache, one thing that is worrying you, and maybe I can find you a company that can help you and have a nice discussion with you.
Actually, it's not. The problem is actually not. We are not looking for the existing problems. We are looking for future innovations, for future functionalities, and that's actually something where we say, okay, we need more flexibility in everything. More flexibility on materials, more flexibility in electronics, more flexibility on the software and all of this. I think that's something where we have to go one step more ahead, where we say, okay, it's not only turning on lights. What we need in the future is communication with our cars and lights, and so we need everything that we can get to make all of this more flexible, intelligent, however. And so actually all fields, I would say, all fields can help, but it's nothing concrete, because it's, yes, you need a big, complete thing. So it's something, small steps would help from everybody who says, okay, I have something new that you haven't seen before, and that it's always helpful.
Oh, you're going to be introduced to many, because already a couple of people asked me to introduce you, and they have something to talk to you about. But I want to talk to François from Renault. Any challenges that you have for the community in terms of reliability, packaging, ideas for collaboration to solve your current headache?
So regarding reliability today, we have no real issue regarding this today. Regarding packaging, yes, we have some issues regarding packaging, because we have we have some good challenge from styling. So we need very compact systems, okay? And as I explained also, we need also to have very efficient solutions in terms of power consumption, and also very efficient in terms of price. So this is the three main topics we are dealing today. So capacity in order to satisfy styling requests, efficiency regarding power consumption, and affordability.
Fantastic, because you're going to love the next presentation. We're going to go all the way to the Netherlands, a beautiful country where I actually live, and we're going to give the floor to Hans from IMS, who's going to tell us exactly how to solve the challenge just proposed by François. Hans, goedemiddag. There's no better time to introduce you than this one, right? The floor and the attention of everyone is now yours.
Thank you, Jose. Let me share my screen. I think here it is. You can hear me now?
Yes, loud and clear. And we can see crystal clear too.
Okay. Hi to the EPIC community, and thank you, Sana and Jose, for giving me the floor for this couple of minutes. And I already heard a lot of interesting challenges where we think we can serve the market with. My name is Hans Velten. I'm responsible for business development at IMS. It's a beautiful country, a beautiful company in the Netherlands. But what we do, first of all, is we are a machine builder and we design and build machines, special machines for small and accurate products. This is our business. This is where we're very good at, and we can help the market with this. Next to the core business of assembly lines, we have our own R&D department, which, as we heard already, is very important because there are a lot of new technologies which we can help the market, our customers, with our own R&D for their assembly challenges. To give you an idea about the company, we are here located at the red dot in the Netherlands, and this is the highest place in the Netherlands. So if we have a problem with our dikes, we are still safe here in this area, just to be sure that's okay. We have some 120, 140 people working at our beautiful company, and our sales are growing. Last year, it was between 40 and 50 million euros. And on the right, you can see this is more or less the automotive industry where we deliver our production lines to. So worldwide, from the small country, Netherlands. Of course, the audience wants to know, how do these machines look like? Now, for the technical people amongst us, this is how they look like. And you also see we do not have any standard machines. So especially for the challenges you have in the market you are working in, we develop and build dedicated machines for that, depending on what you want, from manual to semi-automatic to fully automated lines for the products. So what do we put in all these nice high-tech machines? There's a lot of processes, of course, and I'm not going through all of this, but what is most important and where we can help this challenging market of automotive lighting is the highly accurate aligning of optics. And it's all around this high precision. And it gives also the idea of what we are good at. We feel comfortable in the micron area. Let's say between 0.5 and 50 micron. The accuracy of aligning, this is where we as a machine builder feel comfortable in. So the markets we are working in are mainly three. This is medical, this is smart devices, like these things, and of course automotive. And this is what I want to focus in the last couple of slides I want to show you, because there are some nice challenges. Some examples of products, I want to highlight this one. 10 years ago, we started with production lines for these small products. I hope you can see them. These are micro lenses for mobile phones. So your mobile phone is most probably equipped with a lens manufactured on our machines. And from there, we take the experience and transfer that to the automotive market, which you see here on the right, for the newest generation of light modules. And this is a very interesting aspect. You see here some light modules. And you need, for this newest generation of light modules, you need new technology. In general, we split our activity in automotives in active aligning for three kinds of product groups, as well as the other activity within automotive is the lens assembly. Lenses which are needed for cameras, for LiDAR, and for lighting. I leave this aside, this lens assembly. I want to focus on active aligning. And active aligning is really something interesting new, because everybody's talking about new headlamps, real lamps, HD lamps, micro LEDs, up to even 100,000 pixels, I just heard, and DMD with the Texas Instruments technology. But if you want to assemble these kind of products, you need a new technology, which is not commonly available up to now in the market of automotive lighting assembly. And this is where we can offer great service to the market. What I say here, the assembly is no longer a poka-yoke assembly, but we need a new technology in this market. And the technology is called active aligning. So to give you an example, here you see the newest generation of headlamps with a micro LED with up to 50,000 pixels on a heatsink, and you see the lens array. This is what Audi, Renault, Volvo, etc. want to apply in their car, but the quality of the projection on the road is also based on the aligning of the lens assembly to the micro LED. This cannot be done with a Poka-Yoke, but we have to go to active aligning to make that possible. So you see here schematically a heatsink with the micro LED and a lens array, and we, with, for example, hexapods, we manipulate this towards the lens assembly, and in the meanwhile we look at the light which is shone onto a light interpretation box. And through an interactive process, iterative, we manipulate until we have reached the point where the image quality is optimal, and then we fix the glue with the UV curing. For this we have developed a standard concept which we offer now to the market. We can go through manual or semi-automatic or even automated assembly based on this technology. So finally, what we can do, we can take you steps ahead in terms of technology and in terms of cost efficiency for your newest generation of light modules, camera assemblies, side projectors, and the lens assemblies belonging to them. This is my message, and I think we can serve this market very well with our competences. Thank you for listening and watching.
Thank you so much for the very nice talk. So what kind of collaborations are you looking for?
We work very intensely together with mainly tier 1s and tier 2s. And we are collaborating with them at the end phase of the development of the new generation of products, right before they enter into the market, like DMD headlights, new, and HD headlights with the micro LED. We want to be involved with the tier 1 or the tier 2 at the end phase of the development, so we can together work with them on creating and building the best and nicest assembly machines to bring their products into the market on the most efficient way. This is what we're looking for.
Thank you, Hans. I think someone can comment on this. We have here Hector Frati, who just joined. You heard Jose thanking him in the very beginning about helping us put together all these amazing speakers. How are you doing, Hector? And thank you again for joining.
Yes, very well. Thank you. Just, I would like, maybe not a question, but
sorry, Hector, we have
comments about what I have seen.
Sorry, Hector, we have an issue hearing you. Actually, we cannot hear you very well. Maybe you can fix the mic or something. So meanwhile, does anybody have a question to IMS or a request from IMS?
Do you hear me?
Yes, now I hear you. It's better.
Okay, I can start.
Yeah.
I can start?
Yes.
Yeah, do you hear me? No, just I would like to give you some comments about the different speeches I heard. To start maybe by IMS, I have seen the installation, and really I was impressed by this installation. The other point is about the presentation of Audi, of Volvo, of Renault, and OSRAM Continental, and I am convinced that we could have a very good, a very strong relationship, win-win relationship between the lighting community and the photonic community. Really, lighting community, lighting industry is searching high-tech labs, high-tech company, high-tech startup to help them for the new technologies. And I am sure that the EPIC company will be very interesting to sell their product to the lighting industry. And we could have really a strong, great win-win collaboration together between the two communities, the two organizations.
Of course, automotive lighting is a strong part of the photonics industry, and we are totally aware of that. 3, if not 4 meetings already done. You can also go back to the LIDA meeting that happened, one of the online. online tech meetings that happen. And I would like to hear the comment of Jose here. I'm sure he will have something to say. Jose.
No, all I want to say is that Hector is a rock star. Hector is the hero of today's meeting. It's been a great meeting. Look, Hans, how happy he is. I'm so happy I met you. Honestly, thank you so much for being with us, and thank you for helping Epic reach in the automotive sector. You are my friend forever. Thank you, Hector.
Thank you so much, Hector.
Back to you, Sana.
Thank you so much, Hector. If you allow me, because our friend from IMS, Hans, said he's looking for tier 1, and we have here Valeo, and we would like to hear from Valeo. Gunnar, how are you doing? You are muted. Can you please unmute yourself?
Yes. Can you guys hear me?
How are you? How do you find the meeting so far?
Very interesting. So especially regarding the alignment and the help there with tier 1s regarding the DMD presentation. That was pretty cool. Also previously, we saw in one of the presentations, somebody mentioned a product from Valeo. That was actually the extra view trailer product that we introduced back in 2019 CES, if I remember correctly. So yes, we are very much open to constantly looking for partnerships, especially regarding, in our case, micro LED technology and automotive lighting.
Thank you, Gunnar. And again, please write an email to Jose. He wrote his email in the chat channel. He will be amazing connecting you. I call him the spider. He knows everybody. He will put you together.
The spider, that's cool. You know, Hans, you know what? The CEO and founder of Jasper Display just sent me a text saying, I want to work with IMS. So this is how the magic at Epic happens. This is what a fantastic association we are building. Sana, back to you.
Yes, Jasper will be available to give a talk at the MicroLED meeting that we will have on the 5th of June. And please, if you want to join the meeting, write me an email and we can arrange that. Let me go to our next company, Ficontec. We have the corporate vice president, Stefano. Stefano, can you please unmute yourself?
Absolutely. Thank you for having me. Good afternoon to everybody. So let me share my screen.
Yes, please.
Here we go and share. So hello, everybody. I'm really excited to be here. Thank you for hosting us, and let's go. So here we would like to present a few slides about advanced automation for high volume assembly and testing for automotive light modules. Not very different from the previous presentation. We are a clear cyber physical system builder. So it's a little more complex than machine builder only. There is a lot of software content, artificial intelligence, etc. A company overview, we are 20 years in the market of photonics. We have a global footprint. So we have the capability to support OEM and tier 1s in their 3 major markets. It is North America, Europe, and China. We have today more than 800 machines actually running and delivering photonic system. This is our footprint and our core competency, and of course are all around the cyber physical system. But I would like simply to talk a little about machine software development, where we use, of course, advanced machine vision, artificial intelligence driven inspection software, but mainly also machine learning modeling to provide a very high uptime. We will see in a second. And of course, we also work a lot with our tier 1 and OEM to start to work on their project to build, to manufacture, to design, to manufacture. That is the complexity that the industry has. If we look at the automotive industry critical metrics, the KPI, we need to deliver very efficient total cost of manufacture, both from a CapEx and OpEx perspective. And for this reason, the AI part is important. The manufacturing cycle time, the faster the better, of course, delivering very high yield, so quality and speed of production that often are orthogonal to each other, absolutely deliver a low scrap rate, and of course I already mentioned the APD that need to be very low. So if those are the KPI for the automotive industry, we can address that because we can work with tier 1 or tier 2 in order to support the PPAP and APQP, and of course delivering very low TCM, fast cycle time, high yield, and so on. We have predictive maintenance and global service operation for that purpose. And our focus are production line for LiDAR, advanced sensor, and lighting. And the third, and this is relative, for instance, to avoid any kind of scrap rate down on the stream. If you go up to the stream, you need to have the capability to do wafer level test for automotive lighting component, typically VCSEL, LED, micro LED, whatever is the active part. In that case, is a purely optical measurements that we are going to do and again, on the top right, you see the video that we prepare for a demo for a partner. In this case, what also I want to emphasize is the expertise of the company and of our partners to work with modular instrumentation. In this case, we have PixEye from National Instruments and Coherent Solution for the optical measurement that allow us to do very high parallel counting and measurement that perform a very fast WLT in this specific case. So bottom line, if the KPI are the one that I already mentioned, we can address those, and we work with tier 1, tier 2, often also with OEM, with their R&D to facilitate the design to manufacture of their lighting system. Thank you for your time. And if you have any question, of course, I'm here, as well as the rest of the company.
Ficontec is one of the success stories that we have in EPIC. Thank you so much for a great presentation. If you ever had the chance to go to AKIM and to see real time how these machines operate, you will be amazed. One of the things that, Stephan, I'm quite surprised with the Ficontec technology is how active alignment is being considered as the key solution in the volume production. What are the pull that you're seeing from the automotive market on that particular part, on active alignment of optics and photonics? It's
a good question. The point is the quality, and or if you want the precision of the device that you need to come out. Mainly it is relatively for lighting is important, but for instance, for LiDAR, you mentioned automotive in general. In that case, the alignment of the active device with the lens and with the rest of the system is critical, and so one of our differentiation that we use this active alignment for all our assembling, and we use for that. So that is the main reason. And we can combine, as you mentioned, the quality with the fast production cycles.
Fantastic. I wanted to hear the presentation from IMS and Ficontec on different scales, and then go back to the point of François from Renault. I think it was really good that you told us that the challenge was in the assembly, in the miniaturization and the integration. What did resonate with you after hearing the solutions provided by EPIC members on this particular challenge?
So I think it will be more in the field of the tier 1 supplier to look at this. But yes, we are looking for a very compact solution. So all the miniaturization, you hear me clearly?
Loud and clear.
Okay, okay, thanks. So all the solutions regarding what has proposed, for example, IMS or Ficontec, which can lead to a more efficient and miniaturization of the LED modules, for example, will be very interesting for us. And it will be also interesting to propose this to the tier 1 supplier in order to see how we can integrate it after in the global headlamp with styling in the global car.
If there's something I have learned how the world of photonics works, is that I always get the customer say that he needs it, and then I go to the supplier. So that's why I first go to you, and then I go to Valeo. Because of course, at the end of the day, it's the tier 1 supplier, the one that is gonna serve this industry. From Valeo, what did resonate with you now that you heard Gunnar about the presentations on the automation for manufacturing that is suitable for the telecom, suitable for the space? How can we actually apply this on the automotive lighting to satisfy the need of Renault and Volvo? Gunnar? Yes, we can see you and we can hear you. Yes.
Yes. Okay. So, sorry, can you redo the question?
Yeah, the idea here is that we have a problem. We have an idea of collaborating in the automation for miniaturization of lighting modules, and we have heard active and passive alignment solutions. I would like to see the position of Valeo for the automation of manufacturing of lighting modules based on active and passive alignment.
Okay, well, I'm not sure I would be the best source for that kind of information. But
so I'm going to introduce you to another potential collaborator who is going to help you on this. I have a friend at a company called Aerotech, which is a great company and a huge fan of their stages. Nigel, how are you doing today? We cannot hear you as well as you deserve. So I'm going to go back to you after the next presentation, and my colleagues, who are really, really fantastic, by the way, hello, Suzette and Helena, are going to help you to solve this particular issue. We're going to move to the next presentation today. It's the last but one. I'm having so much fun. I'm so sorry that this is finishing. I'm going to go to Surrey Nanosystems. I owe them a visit in Surrey. It's a great location, and they do the best black coatings. The floor and the attention of everyone goes to Surrey, goes to the UK.
Thanks, Jose.
We see your screen crystal clear, black as it should be.
Okay.
The floor is yours.
Very good. Good afternoon. It's nice to talk to everybody. And for those who don't know Surrey Nanosystems, we are a UK-based company developing super black coatings known as Vanta Black. These coatings are recognized as the world's darkest material, and they are used mostly for stray light suppression in optical applications, in space instruments, camera lens assemblies, automotive sensors, and many, many more. Vanta Black is actually not a standard black paint. As you can see in the pictures, the material has a very unique structure, very rough and you can say coral-like, which allows the coating to absorb light at almost every incidence angle. For automotive usage, we use two different types, Vanta Black SVIS, which is vacuum post-process coating, bringing absolute lowest reflectance of 0.2%. And the second one is Vanta Black VBX2, which is having reflectance in a range of 1% and no size limitation. The real performance of Vanta Black is visible when considering the grazing angles. So you can see in the middle diagram that there's almost no change when the angle is changing. So we're still at 0.6% at 70 degrees incidence angle. And you can see the comparison to the standard coating and to flocking in this very short clip. So when changing the viewing angle, the other coatings become gray, they're sparkling, and Vanta Black just stays black. So what can Vanta Black contribute to automotive lighting? So the modern LEDs provide a really massive amount of light, which is quite good because we can illuminate a lot of area, the big area in front of the vehicle. But on the other side, this light needs to be well controlled. Otherwise, we will get in trouble, for example, with regulation. So we made with our partner ANSYS headlight simulation. You see this on the right bottom picture with, so there is rotating shield, which creates all the different patterns. And it's actually quite nice design and quite good design. The only problem is when you get into manufacturing and there will be some tolerances. So these tolerances can lead to a little bit different shape of the shield, which causes reflections. And these reflections are creating a glare here above the cut-off line. And we're immediately violating the ECE regulation. So what we have done, we simulated, we put Vanta Black in the simulation on some of the faces of the shield, and the reflectances immediately disappeared. And yeah, in this way, we brought the light beam back to the legal standard. Another possibility in lighting is the ADB function, the adaptive driving beam. So you can see today, you know, we are masking the oncoming vehicles with the big square rectangles just to prevent the blinding the driver. But the next generation ADB is targeting just masking the driver's face or even the driver's eyes. So this requires a really, really high shaped beam. And the same applies to the road projection. So symbols and warning signs. When you have reached high quality and high resolution projection, so you also need to have well-controlled stray light. And those are just a couple of examples. I can imagine that there's much more because automotive lighting is growing, growing area. There's, for example, DMD lights. Vanta Black could be the perfect light trap for this kind of headlights. We also, when we talk about integration of LiDAR sensors or camera sensors into the headlights, so those sensors are not allowed to get some stray light from the light source actually. So all those applications could be a potential good fit for our Vanta Black coatings. And what I learned today, the miniaturization, so the headlights become smaller and smaller. So I can already hear the optical engineers screaming that they have no space for the right geometry. So this is also probably an area where Vanta Black can help in the design. My final slide is a little highlight because besides this technical and functional designs, Vanta Black can do much more. Vanta Black is an excellent tool to create very innovative design with really stunning visual effects. So the 2020 Koenigsegg IESCO is coming with Vanta Black lights, and our material reflects so little light that the LED spots in this headlight are just seem to float in space. In other words, Vanta Black is able to to hide the technology and to make the background invisible. Not only in the headlights, also in the tail lights, which opens really the way to absolute astonishing designs, which yeah, of course, supporting the brand differentiation. I hope you enjoyed my presentation. If you have any questions, please.
Thank you so much, Michael, for the very nice talk. I would like to first give the word to the company Mind. Please unmute yourself. Unmute yourself, Yodi.
Yeah.
You have a question? We can hear you. Yes.
Perfect. Just a question. I mean, because all that we see in this presentation about Vanta Black is like based on simulation. But I want to ask you if do you have some examples based on real parts or prototypes about, especially about the cutoff line and to have this cutoff line more clean, as you say, for headlamps?
Oh, I can hardly hear you. It's
maybe you can write as the question. Maybe you can write as the question. Your voice is very far away. You can write it in the chat.
Let me just tell what I understood. You've been asking. You have seen our simulations, and you ask if there are real life examples with applications with Vantablack. Is that correct?
That's correct. That's exactly the question. Yes.
Okay. Good.
Yeah.
So,
yeah. Thank you.
Yeah. So we have done. We have a couple of applications available. Of course, we are very strong in aerospace area. So we Vantablack already, surrounding the Earth on a satellite. That's where we started. And in automotive, we have made a couple of head-up displays, which are also struggling with stray light. And we are also active in the LiDAR area. The automotive lighting is quite new for us, but I can see really a lot of potential here. So, Jose is always asking what we are looking for. So it's exactly why I'm here. So I would like to find a customer or partner, who is interested in improving the performance of his device, or even be enthusiastic to investigate in all those new unexplored cases, which are not yet on the table. Same to styling department. I would love, to be connected with the designers or light designers, which are probably not present here, but I'm sure they will love Vantablack.
Yeah, we have a lot of EPIC members that are working on this, and I'm sure we can connect you with this.
You are looking for a light designer. I have a really good one here in the room. I have my very good friend from Light Tech, Rainier. Thank you very much for joining today. Did you hear that? We have a company, Sorry Nanosystems, looking for help with design of the optical systems. Maybe there's something you can say now.
So I think this is really interesting because we have many customers looking to reduce stray light in their optical systems. So we as Lighttech, we are offering lighting simulation tools like Light Tools or Lucid Shape. And all these technologies are getting new functionalities. That means we are working a lot with imaging functionalities, or mixture between lighting and imaging. And due to the imaging aspects and sensor aspects, everybody or many companies are struggling with stray light. And the biggest goal is to reduce the stray light. And of course, it's always a cost creating factor here. But if we have more materials, or let's say more black materials that are reducing the stray light in the optical system, the better. And we would like to measure this material, or we can characterize this in our laboratory and bring it to our database, because I would like to make this available for all users. So, and this is an interesting point I see. So, the famous actor materials are normally very often on the market, and there were also, I think, there are also EPIC members and so on. But I think this is also an interesting approach here.
Thank you,
So
Rainer.
I can support you and also any other customer with BRDF data, because we have measured the materials and we have the data available, so it can be used in almost every optical simulation software. So if you're interested, we can have an offline talk. I can provide this data to you.
Perfect.
Fantastic.
Yeah. That's great.
I have a question from the YouTube universe, and actually it's from a person that is not in the room, but the company is. It's a question from Ficontec. My very good friend Gregory Flynn is wondering if you have any application in mind in which reducing objects LiDAR scattering is an added value.
We have made one LiDAR application, which I actually presented, I think, during one of the last EPIC meetings, where we could reduce the noise coming from stray light. And the LiDAR was able to recognize the low reflective objects much better than with the standard coating.
Thank you so much. Please allow me to go back on one important topic, the precise positioning. We have here from PI, one of EPIC members and very important company in this field. Ralph, sorry, how are you doing?
I'm doing fine. Thank you, Sana, for introducing me here. Yeah, so one of the last talks we talked about active alignment or passive alignment, and it's a question of positioning tests. I think what we can do is we can support you on different ways. So on one hand, if you go for passive alignment, then you need to make a very precise production. On the other hand, if you don't want to go for poka-yoke and want to do an active alignment, you can also use our components doing some active alignments. And we have seen examples in the presentations from IMS and also from Ficontec. So what we can provide is positioning solutions and not the process in behind, because that's done by companies like IMS and Ficontec, I think.
As you are an EPIC member, it will be easy for us to connect you with everybody here, and you can just shoot an email to Jose, and he will make this introduction easy for all of you. The next talk is by Henny from CEA Leti. I would like to remind you that we have a very important EPIC meeting face-to-face in December in Grenoble at CEA Leti. Can you unmute yourself, Henny?
Good afternoon for everyone.
We're looking forward to your talk, Henny.
Thank you very much. Actually, my talk, it's a little bit an outsider for this presentation. I will talk about the micro LED technology and the possible applications that can be done with it in the automotive field. So I heard from the previous speakers a lot of interest in micro LED. I heard this word many times. Also, I heard the word of miniaturization and integration. This is actually our job in Leti and Grenoble. So,
would you like to share screen or?
Sorry.
It would be nice to, we tried it earlier. Perfect. Now we can see.
Do you see my screen?
Yes.
So we are Leti, we were founded in '67. We are based in the city of Grenoble in France. Around 2,000 scientists working on different fields of technology, especially miniaturization and integration of all kinds of technologies that is in touch with the silicon technology. You can see on the slide the location of our site, and also it's highlighted in green and orange our facility, which are almost 10,000 square meters in clean room dedicated for 200 millimeter, 300 millimeter silicon technology and hybrid technology. So the aims of this presentation is to talk about micro LED technology and the application in the automotive market. So what we do in Leti, especially on the optoelectronic department, we cover all the value chain of the technology in order to do a micro LED array, which could be a headlamp projector, a standard projector, or a micro display for AR/VR application, or a display for a cockpit or car. So to be able to do a micro LED system, we need to pass through the different technology and we need different facility. First, we need to grow the epitaxy. So we need to design and grow the epitaxy, then to do the pixelization to define the form and the size of the pixel. We need to develop the drivers, which are based on CMOS technology, because it's the only technology that is able to deliver very high density current in order to be compatible with the lighting needed for headlamps, for example. And we need the integration, which is the most important parameter, because integration, it comes from one side to connect the electric to the LED epitaxy in order to generate the light, and from the other side is to bring micro LED lenses and integrate them directly on the micro pixels. Then, as all of you know, when we grow a epitaxy in gallium nitride material, we have a blue color. So initially, all LED used in lighting, are blue LEDs, and then we add phosphor on top of them to convert this color to white. What we do also, it's to convert to white and to convert to green and red, because in application like display and micro display, we need the full color. But this is a very challenging topics, because when we do very small pixels below 40 micron till few microns, the color conversion process became very, very complicated. And finally, we need to package. And here there is different type of packaging. We have a standard package. That means we have the light engine. We put optical lenses are not in contact, and then we can work on the design like curving the display in a concave or convex shape in order to simplify the optical system. This technology was mostly used for imager. And finally, we have the characterization process, electro-optical characterization, aging, heat dissipation, etc. So I go back to the integration, because the integration technology, it's our core technology. With this integration technology, we for the micro LED, we have two major solutions. First solution is dedicated to, let's say, big size micro LED, if you allow me to use big size, which means above 10 micron pixel pitch. And with this technology, we are able to hybridize two different materials. So we have a gallium nitride epitaxy on a sapphire substrate. Then we will connect this sapphire to the CMOS by using hybrid interconnection, like microtube, copper pillar, or microbumps. So this technology is limited in resolution. We can achieve maximum 10 micron pitch, but it allows us to go with a more standard process. This technology is compatible with hand lamp application, with VCSEL array for tail lamp. We can do, for example, side mirror projector, or we can do some small display inside the car for specific application. So what we already demonstrate, a 10 micron pitch WVGA resolution with this technology. If you want to go to higher resolution, and here when I say higher resolution, that means we can reach the 1 micron pixel pitch or near the 1 micron pixel pitch. This technology, it's not anymore available because we will face alignment problem. So what we use a monolithic approach, which consists of doing direct bonding of the epitaxy on the CMOS, and then we do the techno of pixelization from the top to the bottom. And with this technology, we were able to demonstrate 3 micron pitch with a pixel of 2 micron and interpixel of 1 micron. This technology, we think it would be compatible with 3D light field display for cockpit, for example, for gaming application or entertainment inside the car. Also, it could be for projection for 3D head-up display. What I did not forget to say is that with both of this technology, we are able to transmit Li-Fi. And Li-Fi, it's very compatible with micro LED technology because Li-Fi in general lighting is limited by the phosphor that exists, the yellow phosphor that exists on top of the blue LED. So if we reduce the size of the pixel and we used, for example, RGB LED without phosphor, direct color generation or native RGB LED, we are able to increase very highly the speed of the data transmission. We already demonstrate with 10 micron blue pixel, a 10 gigabyte data ratio. So this is activities that we are running actually in Leti in the field of micro LED. Thank you.
Hani is a star. Hani is a hero in Epic. Hani is putting us together such a strong supply chain on the micro LED market, and we wanted for you to have a taste of what is happening, what is cooking at Epic on the micro LED community. I think we cover the entire supply chain. There's a lot of possibilities for cooperation. I think the best presentation today goes to Marelli. It was for me fantastic to hear what are the next challenges. So I would like to hear from him at the end. We covered the entire presentation. We covered all the possible challenges. You started the meeting talking about macro trends. What did you learn today? And what kind of cooperations, what kind of challenges, what kind of links would you like Epic to do for you?
I think it was a first opportunity for me to join this meeting. It was very interesting, also very dynamic and interactive. So I liked it very much, and thank you for that, I have to say. So I also understood that there are some additional events which would be of our interest in the future. The one of June the 5th, I think, will be quite interesting, talking about micro LED, which was in the final part of this meeting also touched and where there is a lot of interest. For me, it was interesting also to get this dynamic connection with all of you, and many of them have already texted and written to me. We are already linked in LinkedIn, so I think that there will be some opportunity to talk and maybe do something together.
Oh, don't worry. There's so many people asking me to introduce you. You're going to have a lot of opportunities to talk. I think all of you are going to have a lot of opportunities to talk. I promise you that the meeting will last 2 hours and a half, and it's already 2 hours and 35 minutes. I take your time very seriously, so I'm going to tell you one thing. I did learn a lot about this meeting. While I was chatting with all of you in WhatsApp, thank you for so many WhatsApp messages and YouTube messages and everybody telling me to connect each other. I also took notes, and I put this together this slide in the last 5 minutes of my learning points here. I see some macro trends. I think there was a very good presentation from Marelli. They were talking about the style versus performance, and also very interesting from the presentation that we had from Renault, and especially the presentation that we had from Volvo and from OSRAM Continental. The next stage, integration of security and communication with lighting, LiDAR and lighting together. That's something that is going to be in our minds for a long time. I see 2 macro trends from the photonic side. Obviously, 2 macro trends. First, micro-optics, free-form, high-quality, low-price plastic, polymer. That was for me a key thing that I understood from the needs of the different OEMs, and especially the comments of Valeo, and also micro LEDs. That's a really thing. I put comma because that's a continuing story. We're going to address it again the 5th of June. There's a lot of talk about micro LEDs for this market. On the technology side for automotive, I think the full LED headlamps, as it was said already, 10 years there is still challenges to address on this, especially on the packaging and on the assembly. We talk a lot about the adaptive beam lighting from the OEMs and not so much on the technology suppliers. So in the next meeting I do on this topic, and there will be more, I promise I'm gonna bring companies who can do automated innovation on the scanning technologies without moving elements for this. And this is a big thing for Epic. Laser lights. I really want to have a roadmap on when, by when, and which lasers, which wavelength, and which power, to make sure that they put together the supply chain for this. Digital light was a concept brought together in a couple of the presentations, and glare reduction. On that, the Bata Blanc coatings are a unique selling point, and for me, on the technology side, also the best presentation today. Congratulations, Ari Nanosystems. The real lamps, full LED, but also homogeneous light, and one thing that for me was very interesting, sensor integration, smartness, the idea of integrating sensors with lighting using the right wavelengths. And that's something that we need to address as well in the coming meetings. Electronics, we had a lot of comments from some Microsystems on the chat, so I'm going to introduce them to you, to a couple of you, if they join Epic, which they will, they told me. But also we need to go to printed circuit boards. I think that's something that we need to address, Hani, on the meeting on micro LED. We need to address also the electronics behind the optics, photonics, micro LEDs, and of course LEDs. The biggest challenge was presented by Volvo. It's a very clear challenge. The slides are priceless, so they're fantastic. Innovation is needed for more efficient concepts. I think the active alignment presented by Ficontec and IMS is very interesting. That's why I put this slide here. And also a couple of things that stayed in my mind and will stay in my mind for a long time, because today, in my opinion, today we made history. Today we brought together the automotive industry and the photonics companies, and this is the beginning of a long, long tradition in cooperation. I just would like to say one more thing before we hang up. Very important, because as you have seen, I am here enjoying the spotlight, and I really love it. I could do this for 24 hours. No question about it. I could do this for 24 hours straight without a break, but they have a really strong team behind me and they want to have a beer. So if you want to buy them a beer, you can go to www.buymeacoffee.com/epicphotonics and you can buy a beer to my fantastic colleagues that really want to have a break this evening. And with this, I would like to say thank you for making me so happy for 2.5 hours, an extra 8 minutes. Until the next time, continue being epic. Epic loves you. See you soon. Bye-bye.
Thank you, everybody. Thank you so much.
Thank you. Thank you. Bye-bye.
Bye-bye.
Thank you very much. Bye-bye.